Okay, you should have done your bell work on Go Formative already, and if you haven't done that, please do it. It is for part of your grade, so just because I'm not here doesn't mean you don't do your bell work. I want you to get out this assignment as you watch this video and go over this. To check your answers or fill it out if you haven't done it. I did all three of these, even though I told you just to pick one. But if something's factorable, we want to do that before we start doing the other stuff. Okay, so I just have my work here. So on 22, a lot of you, that's where we were yesterday looking at this. But this is kind of a big idea of being able to get it in this form. Being able to change 8x cubed to 2x cubed minus 3 cubed, and then filling it in that formula. And every single time when you do that, you're going to get one real answer. So one real 0, which is 3/2 or 1.5. And then you do the quadratic formula. There's always a square root of 3 left over. And your very last step, if these are all divisible by a number, then you can simplify it. So then this one we have 2 imaginary and 1 real 0. The second one, I totally messed this one up when I did this, so I had to redo it. I thought it was factorable, but it's not. But I did factor an x out first, so that first line is true. Like, you can take an x out of that. And if you can take the x out of there, that's set equal to 0, so don't forget about it. So this one has a 0 at 0. I thought this was factorable, but it's not, because you can't add to get 6 and multiply to get 7. Like, it has to subtract to get 6. And so you have to do the quadratic formula, which I did over here. And again, we want to simplify this. So a big step to me is getting to this point, and then it's about simplifying. So the square root of 8 is the same as the square root of 4 times the square root of 2. So I can simplify that. And again, just like the one above this, because these are all divisible by 2, I get an answer of 3 plus or minus the square root of 2. You should have work with these answers. If you just have answers, I know you've looked it up somewhere or copied it from somewhere. You can't do this without work, okay? 26, if you did that one instead of 24, again, you can factor an x out. And then instead of having a quadratic left, you have a 4th degree function, but it's like quadratic form. You can do quadratic formula, or this one really isn't bad to factor, because it's just what multiplies to give me 1 that adds to give me 2. And when you solve that, you get plus or minus I. And this is where the fundamental theorem of algebra can be a little misleading, because it's degree 5, and you might feel like you just have 3 answers here. But remember, there's 2 of these, and so that's what we call a repeated root, and it really does count as 5 answers, okay? And then the bottom ones, these are my Descartes rule of signs. So I showed my work here of where I got this. So the positive changes 2 times, so that's 2 or 0. The negative changes 2 times, and since there's 4 total, like, this has to add up to 4. So if there's 2 positive and 2 negative, that already equals 4, right? So that's why there's 0. This has to add up to 4. So if there's 0 positive and 0 negative, I guess I could draw a line like this. 0 plus 0 plus 4 adds up to 4. And then my third option is, what if one of them has 2 and one of them has 0? I would also need 2 imaginary. And so that's how you get those answers. If you don't agree with my sign changes, please talk to someone sitting next to you and kind of look at those to see if you can agree with them. And I didn't do 29 for some reason, but I'll go back here and do that really quick. 29, for positive, I take the signs in the problem. So ignore this one for a minute. I take negative, positive, positive, negative, and I count. It changes 1, 2 times. So I would say 2 or 0 positive real roots. And for the negative ones, every odd exponent will change, which in this one, 5 is the only odd one. So that's going to change from a negative to a positive. But all the rest of them are even. But the constant can't change. So it stays a negative 8. And that one only changes 1 time. So that would be 1 negative. And then, how many does there have to be? Well, the biggest exponent is 5. So I know there's a degree 5. So if there's 2 positive and 1 negative, that's 3. But I needed to add up to 5. So that means there'd be 2 imaginary. But if there's 0 positive and 1 negative, then there would be 4 imaginary. Okay? We're not going to have homework quiz yet because there's one after day 2. And so if you didn't watch day 2's video, you need to do that first. Otherwise, you need to finish watching this and then work on the assignment. The video I know kind of cut off, so I'm going to help finish this one up if you didn't get that last one finished. And then I'm going to help you start on the first one on the homework. So hopefully you can do this and have plenty of time still to work. So again, just like we've been doing, these are the zeros. So like this is x equals 3 because the 0 is 3. So that makes the factor x minus 3. If you think about when we get an imaginary number, they're never by themselves. It's always like plus or minus 2i. So that would give you the factor x minus 2i and x plus 2i. And I think in the video, like I multiplied this out. But I just want you to think for a minute. Some people are much better at going backwards. Like what would you have as a factor that when you solve it, you would get plus or minus 2i? Well, think about, you would have like x squared equals negative 4. So if you move that back over, that would be x squared plus 4 is what gives you plus or minus 2i. So if that makes more sense to you, then do that. If it doesn't make sense to you, you can do what I did in the video where I just FOILed it out. And it doesn't matter where you put the I or the X. What should happen every time is that middle term cancels out. And this times this would be negative 4i squared. These cancel out. And remember that I squared is negative 1. So you get x squared plus 4. But if you can go from here to here and you don't need to FOIL it out, don't FOIL it out, right? It's like making the connection. But I want you to write the function that gives me these zeros. And so then you have to FOIL this out. So x times x squared is x to the third. I'm going to go ahead and say x squared times negative 3 is negative 3x squared. X times 4 is 4x. And negative 3 times 4 is negative 12. And it does say a function. So you either need to say equals 0 here, or you need to say equals y or equals f of x when you do that. And if you solved this equation, you would get back 3 and plus or minus 2i as your answers. And so definitely you're going to practice that as well. Okay, so if you didn't get that in the video, I just wanted to go over it with you. So this is the assignment I'm going to have you work on today. I'm going to help you on 33. So maybe pause the video if you need to get your paper labeled. And then I'm going to help you with 33, and then you're going to do the other ones here. Okay, so I'm going to kind of, I wonder if I can move this away for a minute. Oh yeah. So for 33, 34, and 38, they're just like the first example on this video. And if you can factor, if you notice there's a GCF, if it's a sum and difference of cubed, if it fits quadratic form, then do that. But questions like 33, that does not fit any form that we've done. So up to this point in our life, we've had to just say, we don't know how to solve it. But now we can. And so we can use Descartes' rule of signs to help us if you want. We also could just start randomly guessing if you want to see what happens there. And remember, if it's going to be a 0, it means when you plug in the number, you get 0. So if I just jump in here and I start checking numbers, I always start with 1 in hopes that it works. And I can just type that on my calculator to see what I get. And 1 plus 7 is 8. 8 plus 4 is 12. And 12 minus 12 is 0. If 1 didn't work, I would check 2, or I would check 3, or I would check negative 1 or negative 2. I'll tell you that all of these, you're going to find a 0 somewhere between negative 5 and 5 that you can divide out. Okay? And so since 1 works, just like we did in 6-6, since 1 works, I know that x minus 1 is a factor, or maybe better, since I'm trying to find the zeros, x equals 1 is one of my answers. But don't just keep guessing. Once you find one, divide it out. So since x equals 1 is one of my answers, I'm going to synthetically divide it out. And I'm going to bring down these coefficients. 1, 7, 4, and negative 12. I'm going to bring down the number, multiply, and put it in the next spot. I'm going to add, multiply up by 1, add, and I already know it should equal 0. And then look what we have left. Since this is x to the third, I have x squared plus 8x plus 12. And now I'm going to solve this, because once you get to a quadratic, then you can do the quadratic formula, or you can factor. So I'm going to factor, especially when there's nothing in front, that's just x and x. And I'm going to say what multiplies to give me 12, that adds to give me 8, That would be what? 6 and 2. Plus 6 and plus 2. This one wants the zeros, not the factor. So I have x equals negative 6, and x equals negative 2, and x equals positive 1. And notice I circled that back here so I don't forget. Degree 3, I should have 3 answered circled answers on my paper. Okay? So you're going to do 34 and 38. 34 is just like this. Just start guessing numbers. Maybe work with the people that you're sitting with and split it up. You check -1, I'll check +1, and see if you can get one that works. Divide it out and see what's left. 38 is more like the one we just did. Like on 38, try a GCF first and see if you can factor that. If not, see where you can get, okay? I'm going to post this on Classroom, but just to kind of go over the rest of it with you, 45, that's this one. That's just like the one on the previous page that I just went over. Write them as factors and multiply them out. And then 50 through 52, I'll rearrange this a little bit. 50 through 52, you're matching. So look at the choices here and think about which zeros go with which graphs and what makes it be curvy and not curvy. Think about the degree and the number of turns. And then 56, I want you to just try to sketch a graph that meets these requirements, and we'll see where we get on that. No new video tonight, so work on this. If you get finished, you can work on your Khan Academy, and I'll see you next week. Be good. Stay off your phones.